And welcome back. It is the 29th of April, almost May, which of course is the month of the exams for some of you. Let's see what we've got today. Right, so what do we have? So we've got a ratio, so A to N, N to B is 1 to 2. Well, let's write that down. So that means that is a third, and it means this is 2/3. May not be relevant, but it just allows me to help it. Find the equation of the line that is perpendicular to AB that passes through the point N. Okay, so I'm going to need a couple of things. So first of all, I'm going to need the point N, aren't I? Now, if A to B, so A to B takes me from, well, it takes me from 0 to 12, so it goes up 12, and it takes me from 5 to 0, so it goes down 5. And I know A to N, well, I could just use similar triangles, but I'm going to use vectors again, because I like vectors, and I think they're good to get used to. So it's going to be a third of that, so a third of 12 is 4, that's easy enough. And a third of minus 5 is minus 5 over 3. So not a great number, but it is what it is. Which means that N is going to be the A term, which is 0 plus 4. And the AY value, which is 5 minus 5 over 3. So let's neaten that up. So that's going to be 4, easy enough. 5 minus 5 over 3 on a non-calculator paper. So I'll convert that to thirds. So that's going to be 15 over 3. 15 minus 5 is 10. So that's going to give me 10 over 3. So that's given me the point N. Now what do I need to do? I need to work out the gradient of A to B. And notice my notation. So I'm just saying gradient of A to B there. Now I'm going down 5, I'm going across 12, so therefore it's going to be minus 5 over 12, which means the gradient of the perpendicular is going to be 12 over 5. These are not going to be nice numbers, but let's carry on anyway. Now the line that goes through that is going to be y is equal to 12 over 5x plus c. And I'm going to use the point that I need to go through, which is 10, 3. Let's hope this works out slightly neater than it looks. So 10 over 3 is equal to 12 over 5 times 4. It's not going to be nice, is it? So that's 48 over 5 plus c, which means that c is equal to, now I need to make these 15ths, don't I? So it's going to be 50 over 15 minus 48 times 3 is 144 over 15, which is going to be, well, 144 minus 50 is 94, so that's going to give me minus 94 over 15. I said it wasn't going to be nice. So my final answer is going to be y is equal to, let's get the gradient correct, 12 over 5x minus 94 over 15. Wow, difficult question. Again, as I say very often, not too difficult. End of papery type stuff, but definitely not too hard. Next question. This actually is relatively straightforward, isn't it? So all in one go. So minus means upside down, so I've got 1 over 25. The 2 means square root, so I'm going to square root it, and the 3 means cube it. Again, I think I can do this in one go, but let's do it in steps anyway. So the square root of 1 over 25 is 1 over 5 cubed. And then if I cube the top, cube the bottom, that's 1 over 125. Not terrible, not too bad. Next question. Expand and simplify. So let's do the usual method. So root 10 times root 15 is root 150. I'm going to simplify it afterwards. Root 10 times root 2 is root 20. Root 3 times root 15 is minus root 45. And root 3 times root 2 is minus root 6. Now I can definitely simplify quite a lot of this, can't I? So I'm going to simplify over here. So root 50. Now you don't have to do it in one go. And again, on a non-calculator paper, it might take a couple of goes. That's fine. I do know it divides by 25. So I'm going to say it's the same as 25 times 6, which is the same as 5 root 6. And I can't do any more with that because there's no more factors I can take out. I also know root 20 is the same as root 4 root 5. And again, a bit of experience gets me there this quickly, which is 2 root 5. Root 45, well, that's the same as root 9 root 5, so it's good that I've got some more root 5, so that's 3 root 5. And root 6 is just root 6, I can't do anything with that. So if I simplify this down, so root 50 is 5 root 6, root 20 was 2 root 5, root 45 was 3 root 5, and root 6 is root 6. So all of this gives me a final answer of, well, 5 root 6 minus root 6 is 4 root 6. And 2 root 5 minus 3 root 5 is minus root 5. And that is going to be my final answer. Good question. I like that question. Final question today. Prove that the sum of the squares of two consecutive integers is one more than double the product of the integers. Right, let's read that one again. Prove that the sum of the squares of two consecutive integers. So first of all, I'm going to let integers be consecutive n and n plus 1. And let's just do it stage by stage. So prove that the sum of the squares, so this is the algebra, so n squared plus m plus 1 squared, is one more than double the product. Okay, so let's come back to that in a second. Clearly, I don't really know what to do here, so I'm just going to expand and then see what happens. So if I expand it, I've got n squared plus 2n plus 1, which is going to give me 2 lots of n squared plus n plus 1. Now what am I doing? Is one more than double the product of the integers. Oh, okay. Now, as an aside, sometimes it helps just to do it on this side. What are the two integers? They're n and n plus 1. If I do the product, that's n times n plus 1, and I can see I can turn this into 2 times n plus 1, which is double the product plus 1, which is the thing I wanted to prove. And actually I can just, I've kind of shown it. I've done the maths. That's okay. So therefore I can say therefore proven as required, or just something that shows it, because this is again double the product plus 1, which is the thing I wanted to do. And that's it, today done. That was actually really good. I really enjoyed today. Again, different sort of questions, nice, relatively straightforward questions in the middle, not easy, but relatively straightforward. A couple of harder questions on the outside. Let me know how they went for you. Like, subscribe. Let's see how it is tomorrow. Thanks all.